Good morning, everyone. Thank you for joining. We are here for another webinar. We've got an exciting one today. We are hosting Ivo, head of product at Activeloop, and Mikhail, who is head of community at Activeloop. And we're going to be going through a tutorial that they put together, talking about using their Hub product with Label Studio, which we're going to get into detail about, for a semantic segmentation project. Before I kick it to them to better explain, I want to go through a few housekeeping items, and then we will let Ivo drive. So the first thing to know is we take questions using our Slack community webinars channel. So feel free to join it if you haven't already. It's free, and you can also get questions to answers to Label Studio related questions you might have. And we also have a webinars page on our website where you can see upcoming webinars and watch or rewatch or re-rewatch past webinars that we've done. We have 3 different types of webinar series that we run. This type with partners in the ML Ops space, partner webinars we're calling them, community conversations where we interview folks who are part of our community as a means of inspiring others with interesting projects that are being worked on from around the world. We have a lot of really, really cool stuff that people are using Label Studio for. So we're going to be doing more of those in January. And then we've also got, of course, tutorials. We have a couple of important ones coming up before the end of the year that have been oft requested by our community. One around a new feature that's forthcoming, video annotation. This has been a long time coming. We have some special announcements from our CEO that are going to be coming via our Slack community later this week with respect to video annotation. So if you're interested in that, there will be more info dropping before the end of this week. And then we're going to go through how to build custom front ends with Label Studio, another product related tutorial before the end of the year. We're putting together our Q1 2022 schedule right now, but we're close to finalizing with a cadre, if you will, of 6 webinars for January through March of 2021. And I'm pretty excited. We're going to have that slate up at the webinars page by the end of December. Hopefully we'll start populating it by the beginning of December, by the end of November. So the last thing I want to mention is about Champions program. So we've got a new Champions program that we just launched. It's very basic now, but we're adding to it. We're going to be iterating on it often. We have a kind of special weekly activity that you can only redeem this week for more points than you'd normally get for something like that. So feel free to check it out. It's in the leaderboard. It's worth 20 points, and you can only redeem it until the end of this week. So if you head to that URL, basically our Champions program gives you points for doing things you may already be doing if you're a Label Studio user, and lets you redeem them for some fun prizes. And then I'm not gonna. This is my only plug for you guys, and I'll kick it to you, Ivo. I'm sure you've got better links, but this is. Thank you, Mikhail, for getting this published late last night. This is the blog that you can follow along this tutorial with. I put a little bit.ly together, but essentially this is meant to be something you can refer to while we're doing the live stream after the fact. And you can go to that bit.ly now if you want to follow along during the live stream. And the last thing I will say, here are some for those of you coming from the Activeloop side of the house joining us, welcome. If you're not already familiar with Label Studio, we would love to familiarize you with it. Here are some links that will help do that. Labelstudio.io is our open source website. Hardx.com is where you can find more about all editions, including enterprise and teams. We have a monthly newsletter. We've also obviously got our Git repo, and then of course the Champions program I mentioned. And that is all the plugging I will do. Let's get into the meat of the substance. Ivo, the floor is yours.
Awesome, thank you.
Thank you.
Let me share my screen here real quick. Cool. So yeah, I'm going to give you a little bit of a background of our company, and then we'll get into the demo itself. And apologies, we have some animations that we're going to be showing. Hopefully, it's not coming up as too choppy on your end. So you should see basically something like a spinning galaxy at this point. So quick background on the company. So the founder of our company, I'm not one of the founders. I joined later, but both the founder and myself, we both experienced a very similar problem at different stages of doing deep learning. And that's the fact that when you're doing deep learning with lots of images or unstructured data in general, you kind of end up having like a rat's nest of files all over the place for which you need to write a ton of boilerplate code to essentially determine like all the relationships between your data, like your images and your annotations, for example. And the more complex your data sets are, the more of this boilerplate you generally have to write before you can actually train machine learning models. And then on top of all of this, with your data stored as files, there's generally very poor visibility of your data. You need to write kind of notebooks where you're maybe using PIL or matplotlib to visualize your data, but it's all just very cumbersome. And so it feels it's like very much like operating in the dark. And so this is one of the problems that we want to solve at Activeloop. And so one of the things we're doing is essentially building a data set format for unstructured data that basically provides structure to your underlying data so that you can do all the things that you need to do in machine learning just without writing all this boilerplate code. And then there's this whole streaming element to it that I'll discuss in a moment. And this came at a really good time because especially this last year and this year, data-centric AI has become a really big trend in machine learning in general. And it was started by Andrew Ng. And really what this means is that people are starting to buy into the notion that good quality data is really a prerequisite for having great models. You know, in the past, people were spending a lot of time on optimizing models, trying new architectures, more on kind of the compute side of things, but it's kind of like a garbage in, garbage out problem. And so you really need to spend a lot of time making sure that the stuff that you're throwing into your models, namely the data, is high quality. And so Activeloop and Label Studio are two companies that are really instrumental to doing this. You know, if you're doing any kind of supervised learning, great labels are an absolute must. That's where Label Studio comes in. And then Activeloop, we're a layer on top of this that allows you to go through the iterations of updating your data and visualizing your data much more efficiently. Because typically, you know, you're labeling, you end up having to do this more than one time. It's not kind of like a static problem that's one and done. It's an iterative process. And so, yeah, at Activeloop, we really provide a solid foundation for our AI. So a couple of things that we offer. One is a simple API for creating, storing, and collaborating on AI data sets of any size. And I'm going to go through that API in the demo. Number two is the ability to rapidly transform and stream data while training models at scale. So you can basically connect your data to computation in a streaming sense. So if your data is in the cloud, you can connect them to a GPU without having to download anything locally, for example. And then lastly, we enable you to instantly explore and visualize your data sets through our web-based browser application. And so all of this is done so that you can get more accurate and cost-effective AI models at the end of the day. And really what our technology is at its core is essentially, if you start off with messy computer vision data, for example, files for your images and annotations, we essentially pass those, when you insert those into Activeloop and into the underlying data format that we offer, that data becomes neatly packaged into tensors that have an underlying structure. So those tensors enable you to stream the data much more efficiently to your GPUs or wherever they need to be consumed by computations. And they also enable you, by providing the structure to the data, you have to write a lot less boilerplate code to actually use the data itself. And then just to kind of talk a little bit about the streaming element in more detail, I'll kind of show you kind of two worlds, the old world and the new world. So typically, if you're doing deep learning right now, especially if you're on a team, different people need to have access to your data. So you might have a data scientist that has a laptop, maybe there's a SageMaker notebook, Label Studio needs to have access to the data, or you have a multi-GPU training job. The old way of sort of handling this problem is just copying this data back and forth. So maybe you'll have an S3 bucket and then you copy your data to all of these different places. Those different tools consume the data, do whatever they need, and then push it back to the S3 bucket. But the challenge is if anyone makes any change, there's this whole synchronization problem behind this that becomes pretty tough. And then also the copying in and of itself, especially if you have very large data sets, can be very, very, very time consuming. And so what this looks like with Activeloop is your data lives in a central storage location, like an S3 bucket. It could be your own cloud. We offer storage of our own. And then that data is streamed to all the parties that need to use it in real time. So your data scientist laptop, a SageMaker notebook, essentially data arrives in these different locations on demand only as needed. And it's all coming from a central storage location that has essentially the ground truth view of what this data looks like. And just to show you what this ultimately enables is an experiment that we essentially did with Objectron. So Objectron is one of the most popular computer vision data sets offered by Google. And it's a huge data set. It's over 2 terabytes of data. And so if you want to use Objectron sort of in the old way of doing things, it takes you about 40 hours to set everything up. So you have to spend about a day downloading the data. You have to spend a couple of hours unzipping all the files, unpackaging the API, understanding the TF records. And then finally, after about 40 hours, you can actually use the data and do something with it. With Activeloop, since A, the data is structured, and B, it is streamed, you basically just slice out all of these steps. There's no downloading, there's no unzipping. You pip install hub, and immediately with one line of code, you can access the data and start training models or whatever else you might want to do with it. And then another kind of performance benchmark we have to show how effective this is we actually trained the ImageNet data sets. It's a 1.2 million image, 160 gigabyte data set on SageMaker, and we're training it from an S3 bucket. So typically in sort of the status quo SageMaker, what you would need to do in order for the training job to run is you would run what's called AWS file mode, where basically data is downloaded from the S3 location onto the compute instance that's doing the training. That process would take about 3.5 hours. And then you'd actually train the model for one epoch for 1.5 hours. So essentially 4 hours total, most of which is actually spent downloading the data. Then AWS introduced this notion of fast file mode that essentially streams the data from the S3 bucket to the training instance. And it works pretty well. You can cut this down to about 2 hours total. So the training is a little bit slower, but you don't have all this downloading. And then we have Hub. So this is the exact same data set in an S3 bucket. All these data sets are in S3 buckets, but in the Hub bar here, the data set is in Hub format. And really what this format enables you to do is to stream this data much faster than it's in files, which is ultimately why this training was faster than any of these other ones. So essentially, the second the training job gets kicked off, data is streamed. There's no sort of prerequisite data downloading that needs to take place. And end to end, you end up with a much faster workflow. Cool. So that's pretty much it for the overview. Now I want to jump into the demo itself. So in the demo, we'll show you again what the labeling, how you would label data with Label Studio for a particular data set that we're going to be using in this demo. And then I'm going to show you an example of how you would convert that data set into Hub format. And then also once you have it in Hub format, what you can do with that data set. So I'm going to pass it off to Michael for the piece on Label Studio.
All right, let's determine some smiling. So once you've installed Label Studio, you're going to create a new project, and we can call it Smile Brush Segmentation. Actually, by the way, you can find out more information about how to install Label Studio when you go to labelstud.io and check the docs. There's a lot of information, a lot of different ways to do it. Next slide, please, Ivo.
Mm-hmm.
Once you've created your project, we're going to select the Semantic Segmentation with Polygons setup and press Save there. Next slide. We've got, I'm sorry, if you go to the previous slide, we've got a lot of helpful templates that you can choose from. If you go to the previous slide, sorry about that. That support a lot of different types of data annotation. Obviously, we're showing sort of polygonal segmentation, but there's a lot around natural language. Video is coming soon, time series, we have that, audio, waveform, etc. Lots of really good templates here, and you can, of course, create your own custom setups as well. All right, next slide, please. So going down this list, let's look at these folks on the right here. This is our list of data of people, pictures of people smiling. So let's target this guy, 1191, shall we? Is that a smile, or is that's one of those sort of smiles that could be a frown, but no, that's a smile. So we're going to go ahead and take our brush tool and we're going to select the smile region. We're going to label that a smile, smile number 1. Next slide, please. And thank you, by the way, Activeloop, for these great GIFs. Mikhail, probably, you're a GIF wizard, I can tell. And then we're going to export our annotated data set as brush labels to PNG formats. And I will kick it back to you, Ivo, for what happens next.
I was muted there for a second. So let's actually jump into the demo. So we'll shift from slides to actually talking about notebooks. So basically where we are at this stage is we have a data set that we've labeled with Label Studio. It basically has pictures of people, and it has files corresponding to the masks for the annotations that we just created. Now, the first thing we're going to do is actually upload this data and convert it into Hub format. But one thing I want to give a shout out to is, so right now, essentially, we took Label Studio and we exported the labels and the files from Label Studio in file format. One thing that we really want to build, and that we're going to build by the end of this year, is actually a direct integration between Label Studio and Hub. So essentially, Label Studio, you'll be able to export the data not as files, but also data in Hub format. And if this is something that's of interest to folks on the webinar, we'd love to hear from you so that we can sort of prioritize that accordingly. So please email me at ivo@activeloop.ai, and we'd love to hear from you if this is something that sounds like you'll be useful for your workflows. But nonetheless, that's not ready quite yet. So essentially, we're still, what's coming out of Label Studio is still files. And so the first thing we need to do is import those files and convert them into a dataset format, into a Hub dataset format. So in this notebook here, first we pip install Hub. Hub is a Python package. It's open source. We import it, and then we just import some other tools that we're going to need throughout this notebook. And then we'll check out some, just kind of sanity check that what our data set looks like. So we're just going to inspect our folder with where the images are to see how many images and masks we have. And then let's actually display some of these. So here we have a person. Again, still we're reading the data set in file format. So here we have a person corresponding to the smile masks. So these look pretty good. Here's another one, and there's their mask. So we're just checking out our files and our masks to make sure that everything makes sense. So now let's actually put this data in Hub format. So the first part of creating essentially a Hub data set is to create an empty Hub data set somewhere. So that's what's done here. So this hub.empty command creates a Hub data set at this particular location. Now this prefix here is telling you where the data set is stored. So this prefix being Hub means it's actually being stored in Activeloop's storage service that we offer. But this can actually be something like S3, where this is bucket name. And then this would be your own S3 bucket. Or you could actually do GCP. That would store the data in your own Google Cloud, or this could actually just be a local file folder. So that would store the data locally on your computer. So basically, you know, Hub is what underlies everything is really a format, but that format can live pretty much wherever files can live, whether it's an R storage, a local storage, or a Google Cloud of your own. And so in this case, as I mentioned, we stored it in Hub. And then so what does the actual underlying format look like? So all of our data is arranged as tensors, essentially large arrays. So therefore, what we do is first we run this command dataset.createTensor, where we create a tensor called images. And then we create another tensor called masks, because that's essentially the data that we have here. We have images, we have masks, and that's our data set in a nutshell. And then all we do is just run a for loop where we basically iterate through all of our files, and then we append to these tensors. So ds.images.append, and then we read in the file name for where the image is. dsmasks.append, and then we read in the file for where the mask is. And that's it. After we run this, the data set is in Hub format in this location. It's the same information content, just arranged a little bit differently. And then here now, excuse me, we actually read the data. So from the Hub data set. So we do plot.imshow, and then we read the first image. So Hub, everything is basically indexed. So your tensors have essentially an index position like 0 through 50, since this is the 50 image data set. And so here we're plotting the 0th image, and there it is. And then here we're plotting the 0th mask. And so there's that as well. And then I'm not going to go through this, but we basically do this twice, once for the testing data and once for the training data. And then the next thing we can do is actually train a model. So I have a separate notebook for this. So again, different collab, we pip install Hub, we import it, run some packages that we'll need to use. And then now, since the data set exists, all we need to do is load it. So this command hub.dataset, or there's another one, similar alias called hub.load. You just run that, specify the path to the data set. Again, it could be hub, local, S3 bucket. And once this executes, your environment is immediately connected to this data. And so this is really the power of, no downloading is necessary here. Like one line of code essentially connects your machine to the data, wherever it may be. And then just again, let's do some sanity checking. So we print the length of the data set. This is how many images we have. Let's print the 0th image. There it is again. The mask, the 0th mask, there's that. And then, we're pretty happy that this data set looks good. So let's actually do some training. Oh, and just one thing I forgot to mention. Again, when you do this command here, dataset.mask of index 0 or whatever index you choose, as that is executing, that data is pulled directly from the cloud. So we try hard to make this feel like you're working with lists or NumPy arrays in terms of what the API looks like, but what's actually happening under the hood is the data is coming potentially from the cloud if it's stored in the cloud, or locally if it's in a local folder. And then since we're training here, we're going to be training with TensorFlow, so we want to create a TensorFlow data set. So we define a function that'll essentially pre-process our data to the specified batch size and the specified resolution. And then we have this hub provided function called DS. So DS is a hub dataset object. So we run .tensorflow on that, and that gives you back a TensorFlow dataset that behaves just like a TensorFlow dataset as if it wasn't created with hub. And the cool thing about that is this TensorFlow dataset now, as it's pulling data, is going to be doing so directly from the cloud. And we have a very similar integration with PyTorch that I'll talk about in a moment. Now let's just sanity check our TensorFlow dataset. So here we have a person, we have their mask, so that looks pretty good. So now we're ready to actually do some training. So we're going to be defining a UNet for this particular training job. And then here we initialize the UNet. And then here we define our model. And then we actually train it here when we run this model.fit command. And so here's the training process. Training was completed. And so now let's actually test out what the performance of this was like. So let's load our testing. As I mentioned earlier, we created a testing data set and a training data set. So now let's load our testing data set. There it is. And then we basically write a couple of functions to be able to perform segmentation on that data set. And then let's actually run some predictions. So here those are. And here are the outputs for those predictions. So here we have, we'll just kind of spot check a couple of these. So here we have a person and the predicted mask. This one actually doesn't look so good, but this one, for example, is in roughly the right spot. So is this one as well. So there's some erroneous values here, but our training was pretty decent. We have at least a reasonable baseline where these masks are being predicted fairly well. And so this is a tutorial you can follow. It's it all works in Colab. It's pretty lightweight, not a whole lot of intensive compute going on here. But what I want to show you an example of what this looks like when you actually have very intensive compute. So I'm switching here to actually a SageMaker notebook that's running on a Tesla V100 GPU. And what we're actually doing here is training the ImageNet data set. So 160 gigabytes, 1.2 million images. And again, we have this data set in hub format. So here what we do is we run hub.load. We specify the data set path. So this is in an S3 bucket. And then we define a transform to pre-process our data. And then we define a batch size. And then this is the really cool part here. So we run this command ds.pytorch. And the output of that is a PyTorch data loader. So as this data loader is iterating, it's pulling data directly from this S3 bucket and constructing batches of 64, and then passing those straight into a model. So this hub data loader behaves just like a PyTorch data loader. Basically, wherever you have, whoever consumes this PyTorch data loader can consume the hub version of it, or the like native PyTorch if you were doing this with files. So it works exactly the same. And then we enable you to do some multi-processing by specifying the number of workers. You specify a transform and the batch size. And then here we define a model. We're going to use a ResNet 50. I'll skip over most of the model related things. We define a training script. and then let's actually do the training. So once I run this train model command, I pass in the hub data loader and the model, and let's check out our output. So this whole process took about 1 hour. And the cool thing to notice here is that our GPU utilization as we were training this model was really, really high. So it was about 90%. And getting high GPU utilization while you're training is really, really important because your GPU is typically your most expensive resource. And so essentially, if this number isn't high, you're basically incurring higher training bills than you really should. And the fact that this GPU utilization is high is a testament to how fast the streaming is. This is a pretty powerful GPU. It's very thirsty for data. It's processing data really, really quickly. And the fact that the utilization was high means that the streaming of that data from the S3 bucket to the GPU was not a bottleneck. And it was not a bottleneck because when data is stored in hub format, when it's in chunked arrays, that ultimately enables it to be streamed across networks much faster than if you were doing this with files. And then the last piece I would like to show you is actually our another thing that leverages data streaming quite a bit, and that is our visualizer. So this is a web-based tool, app.activeloop.ai, where you can visualize data sets. And so what we're looking at here is not just pictures of apples. This is actually the ImageNet data set being visualized. So here we have the image as well as its label, and then we can toggle either one of those on or off. So these are essentially the tensors that we have for this particular data set. And the cool thing about this tool is that we're able to visualize enormous amounts of data really, really quickly and really, really easily. And this is really key part of the data-centric AI movement. If you're doing, especially if you're using, if you're sort of building models for custom applications, you're going to need to look at lots and lots of data, iterate through your labels, change sort of labeling rules and labeling standards. And there's really no way around the fact that you're going to need to spend a lot of time looking at data to make sure that it's high quality. And this tool that we provide is a really great way to do that. And again, just like all the other Activeloop products, it doesn't matter where the data is stored. You can connect data as long as it's in hub format. So as long as your data is in hub format, you can connect it from your own buckets to this tool. You can connect it you can use our own storage if you want, or even local files. And cool, yeah, so that's pretty much it. Let me just show you one more slide about other things that we have coming in the pipeline. So I showed you the open source project, which is essentially the underlying data format plus the API. Showed you the visualizer, but actually on top of the visualizer is where we're building a lot of really cool things. So we're offering actually version control. So you'll be able to version control your data just like you do in Git, where you can commit, branch, merge, and diff your data sets. We're going to offer you the ability to perform computations in a highly parallelized fashion. So you can either do them in parallel on your local computer, or you can do them on a cluster. And we'll actually, just like kind of like the Databricks experience, give you the ability to spin up a cluster and immediately do some sort of pre-processing on your data. And then last but not least, we're going to enable you to do querying. So through the visualizer that I just showed you, you're going to be able to run SQL-like queries for unstructured data based on any properties of your images or your labels. Oh, and then also, yeah, very importantly, we're really excited about this Label Studio integration that basically connects Label Studio directly to hub format, so you don't have to go through files as an intermediate step. And if you're interested in any of these things, we'd love to hear from you. So I'm Ivo. My email is ivo@activeloop.ai. So please send me a note if you have any thoughts or questions.
Awesome. Thanks, Ivo. And we can just leave this slide up here. This is great for me. These are some good links for us. Yeah, we're on Twitter, HardX Labs. And of course, check out our Git repo. Leave us a star if you would. And if you wouldn't mind liking this live stream, this video, feel free to share, subscribe, all that good stuff. I feel like a YouTuber now, a real YouTuber. But thanks again, Ivo. Thank you, Mikhail. This was great. And see you guys again very soon.
Thank you.